My name is Dr. Quintanilla,
My name is Dr. Grogan. My name is Dr. Meisner.
My name is Jeff.
and this is the diffusion through a membrane lab. The problem in this lab will be how does solute concentration influence the net movement of water molecules through a semi-permeable membrane. The variables in this lab will be the molarity of the sucrose solution in each dialysis tube, which is the independent variable. The dependent variable is the change in mass of the dialysis tube due to the movement of water into the tube. And the control in this lab will be the dialysis tube filled with only distilled water submerged in the distilled water beaker.
In front of me, there are the materials for the diffusion through a membrane lab. In this lab, we will use a canister of distilled water to my right. We will use five different solutions of sucrose of varied concentrations: 0.2 molar, 0.4 molar, 0.6 molar, 0.8 molar, and 1 molar. We will place these different solutions, in addition to distilled water as a control, into 6 different cups. We will then put the dialysis tubing full of these solutions in the cups. Before and after they are placed in distilled water, we will weigh them on a scale to my left. Here on my left, forward, is the 6 dialysis tubings that have been pre-soaked in water that we will use for the lab. We will also be using this funnel to pour the various solutions into the dialysis tubing. We will also be using this blue calculator to calculate the change in mass before and after the dialysis tubings are placed into solution.
So what we're doing is we're filling the dialysis tubing with 0.8 molar solution of sucrose, and you want to put about 10 milliliters of this solution into the tubing. Probably gonna need more. Then you want to fill it up to about almost above halfway, and then you want to tie the tubing and make sure it's tied tight.
After you are done filling up the dialysis tubing, here we have the distilled water, we have the 0.2 mole solution, 0.4, 0.6, 0.8, and the 1 mole solution. After you are done, make sure you dry them thoroughly so they are not to alter the masses when you weigh them on the scale. You want to make sure you get it in paper. There we go, nice and dry.
Now that we dried the dialysis tubing, we can take an accurate measurement of the mass. Now that we've recorded all the masses, we will now fully submerge the solutions.
We will leave them immersed in the solutions for 20 minutes and then weigh the dialysis tubings to observe the change in mass.
And when we're done, we can't clean up the other one.
Now that we are done waiting the 20 minutes, we will take the dialysis tubing out of their solutions, where we will dry them thoroughly once more before we reweigh them on the scale. We are now taking the dialysis tubing out of the 1 mole solution. We are drying this bad boy. Almost ready. Now that it is nice and dry, we will go and take it and remeasure it.
Yeah.
Alright, we will now weigh the 1 molar solution of sucrose. So that says 30.8 grams. If you look at the table on the left, you can see that as the molarity of the sucrose solution increases, the resulting percent change in mass also increases. And if you observe the graph on the right, you can see that there's a direct relationship between the increasing molarity of the sucrose solution and the resulting change in mass. The purpose of this lab was to observe how solute concentration affects diffusion through a semi-permeable membrane. The materials used for this lab were 7 plastic beakers, a 10 milliliter graduated cylinder, 6 dialysis tubes, distilled water, 0.2 molar sucrose solution, 0.4 molar sucrose solution, 0.6 molar sucrose solution, 0.8 molar sucrose solution, and a 1.0 molar sucrose solution, a scale, a calculator, and a funnel. After we conducted our experiment, we discovered that there is a direct relationship between the amount of solute present in the membrane and the amount of water moving through that membrane. Our results show that the mass of the tube changed more when there was a higher concentration of sucrose present in the dialysis tubing. This is due to water always moving from a low concentration of solute to a high concentration of solute.